So as you think about those 6 items that you just read, one of the things that you just noticed was that if I'm looking at the function y equals log base 7 of x, I know that the domain is going to be parenthesis 0, comma, infinity, parenthesis. So what does that mean in terms of our graph? As you look at this graph, you'll notice that we can't plug in x values that are to the left of the y-axis because the graph doesn't live there. Also, I can't plug in an x value of 0 because the graph doesn't live there. I can only plug in x values that are to the right of the y-axis. Now, another way of saying that we are living to the right of the y-axis is to say that our x values have to be greater than 0. Now, a more general statement is to say that the argument of our logarithm has to be greater than 0. Now, if I know that the argument of my logarithm has to be greater than 0, I can also say that the argument of my logarithm has to be positive. So you want to keep that in mind then as we're doing example 4. In example 4, they're asking us for the domain of a logarithmic function. F of x equals log base 7 of x minus 3. Now, once again, the argument of my log has to be positive. So the argument is the stuff inside the parentheses, the x minus 3. And in order to say that that has to be positive, I can write this as an inequality. I'll have a 0 on the right-hand side, and I have to have a greater than symbol in between. So once again, my argument has to be positive. One more time, another way of saying that is that x minus 3 has to be greater than 0. So now that I have this written as an inequality, I can solve it. Add 3 to both sides. I know that x has to be greater than 3. Now, we know that this is never going to be an acceptable answer in this class because the two notations we can write down for acceptable final answers would be set builder notation or interval notation. I'm going to go ahead and choose to use interval notation here. I'm going to write down parenthesis 3, comma, infinity, parenthesis. There's the domain of the function f. Now, as you look at this, what this allows us to do is actually finish a story that we started earlier in the semester. We talked about problems earlier in the semester where we would have something like the square root of x minus 3. And if you were trying to find the domain of g of x equals the square root of x minus 3, you would take the rada cand x minus 3 and set that greater than or equal to 0. But if you were looking at a rational function like h of x equals 1 over x minus 3, in that case you would take the denominator, x minus 3, set that equal to 0, and find the x values that you would need to exclude. So now we have the idea that there are in fact 3 different things that you need to think about anytime you're doing a domain problem. So if you're looking at a domain problem that starts off with a square root, you take the radicand and set that greater than or equal to 0. If you start with a function that is a rational function, you take the denominator, set that equal to 0, and find the x values that you need to exclude. And now the third part of our story is that if you're looking at a logarithmic function, you take the argument of the log and set that greater than 0 and solve and see what x values you can use. Now that we have this idea, I do want to make a compare and contrast statement here. Notice that when we were doing the radical statements, we had greater than or equal to, but here in log world, we simply have the strict inequality. It's greater than. So we could actually take the square root of 0. That's why we included 0 when we were doing radicals, but we can't find the log base 7 of 0. That's why we're not going to include 0 in this world. So it's a good thing to remember then, we do include the 0 with things that are simply square roots, but we never include that 0 when we're talking about logarithms.